Okay, so this is week 5. You should see the main class portal right now with my mouse moving kind of in a circle slowly. I don't want to give you any dizziness. If you don't, let me know. So first things first, if you go to content and actually, why don't I make myself look like a student so I show you what you see. All right, if you go to content, and if you go to course outline, again, the second document that's there, that's a course plan. You can download that. I'm pretty sure most of us already know that. And that's what it looks like when you download it. And you can see here, right, this table here, that's the tally of the quizzes and tests and all the, well, that's the evaluation summary here. You see here, each quiz is worth 5% of the total mark for the course. And so if we scroll down, you're going to see our calendar type of a view for our course. And today is October 2nd. So we are week 5, October 2nd to October 6th, Monday to Friday. So that's the date span for the week. And look at this thing here. Oh, we're going to have quiz 1. All right. So quiz 1 is going to be online, and I will deploy that quiz sometime later on today. And I'm going to give you the instructions of how to get there. So everything should be nice and clear. Now, this week, this quiz is going to last, well, it's a short quiz, just 10 questions. So let's see the calendar here. Today is October 2nd, 3rd, and 4th. 2 days should be enough for you to proceed with that quiz. However, if you want, I can extend that to Thursday, Friday, Saturday, and Sunday, and maybe even Monday. So it's going to be it's going to close at midnight or 1 minute to midnight on October 9th. That's not the official date because Thursday, Friday, Saturday, well, Tuesday and Friday, there is no school this week. And Monday, I think it's also, that's the Thanksgiving weekend. I think that's what it is. Right? Right. Here. Okay. So the official time for the quiz is 2 days. Usually, if you were in class, you would get 1 hour to write that specific date. But since it's online, we got the convenience of doing it this way. So the official time for the quiz is Tuesday and Wednesday, tomorrow, and the day after tomorrow. This here is just an unofficial bonus that you can just have. The quiz is going to close Monday night, 1 minute to midnight. And there will be no extensions for the quiz. The quiz is going to have unlimited time. I'm not putting a time cap on that. So people who need double time for that, well, you do get double time, but you don't. Because if the time is unlimited, then unlimited times twice is, well, still unlimited. Get it? Okay. So look for the email, look for the announcement for the quiz to be deployed. It's going to be online, open book quiz. All right, that's as far as that. Today, one more thing. This is just one class today. Since the time for writing the tests and quizzes is allocated during the regular in-person time or online or whatever it's scheduled for the class time, there will be no class tomorrow. Use that time to either study or to write that quiz. Right? So there will be no in-person class tomorrow. That's designated for writing the quiz. Okay? So it's just the online class today, this week only. All right? Cool. Let's start with the lecture. And okay, the quiz is going to be on anything that we have done until last week. Since the boxes and devices are two parts, which is going to be first part today online, and the second part is going to be the class that we'll have in person. That is going to be week 6. It's going to be October 10th. So the boxes and device, today's class is not going to be included. It's not going to be included in the quiz. It's just everything from week 1 to week 4. Okay. That said, let's start our class. So that's the first part, 1 of 2. And, well, of course, if you're watching this thing on YouTube, there will be no part 2 of 2 posted on YouTube because the second part is going to be in person. Right? That's how things roll this year. You're welcome. I'm just looking at the chat here. Cool. All right, so boxes and devices. So we have until now, since the beginning of September, we have studied few things. We studied some of the multimeters, and we studied some other things. Now let's have an easy type of. This is going to be an easy type of lecture. It's to familiarize you with different types of boxes and devices that you might encounter during your work time. All right, let's just see what we have to deal with. All right, so boxes and devices, part 1 of 2. All right, of course, most of the presentation, some of the presentations will start with something that is funny. Okay, now this is funny. I don't hear you guys laughing because you guys you have your microphones turned off, but that's your cue to start laughing. All right, do your part. Come on. So don't do that, kids. Don't do that at home. Don't do that anywhere. There are certain rules that we need to follow as far as filling in the boxes with the wires. And we're going to touch on some of that subject as we go along today. So let's see what we deal with as far as filling the boxes with wires. By the way, remember when during the lab we were talking about there you go. Some people are laughing. I can see it, right? LOL, that means somebody is laughing, right? All right. Remember when I talked to you during the lab time when we were terminating the duplex receptacle in a utility box that we mounted on the wall? I said that the minimum length of the wire from the point that it's coming out of the connector in the box to the point that it hits the screw terminal should be minimum 6 inches, or what's official in Canada, because we are in metric system, 150 millimeters, right? Which comes up to about 6 inches. Now, also, I mentioned that, yeah, well, we should have something like, 6 to 8 inches to be comfortable both ways. One is that we should have a minimum length of the conductor. Second, don't make it like 25 inches or so, because you're still going to have to pack those wires inside that box. And the box is only so big, and it's not made out of rubber, it's made out of steel. All right. So, Canadian electrical code. Even though I don't teach, this is not a code class. You have another class, that another subject, another course that teaches you the code. However, once upon a time, we are going to mention CEC, which stands for Canadian Electrical Code, because we're in Canada. All right, so CEC determines the amount of wires an electrical box can hold based upon the following things. Let's see. Well, the total volume of the box, and it is specified in milliliters. A liter is a unit of volume, and a milli is a prefix before the liter, and milli means 1/1,000. So in thousandths of a liter, so milliliters. So again, the CEC determines the amount of wires an electrical box can hold based upon the following things: the total volume in the box in milliliters, the size of the wires in American wiring gauge, and the type and size of the device mounted, because some of the devices are bigger inside than others. So of course, if it's a device, like let's say, if it's just a regular duplex receptacle, it's going to be smaller in size than something that's called GFCI. Ground fault circuit interrupt. We will touch on what's going on with those, but there's some circuitry involved, and that receptacle is bulkier. It takes more space in the box once you put it in the box, which means that you can have less wires there. Right? The type and the size of the devices in the box, switch or GFCI, and the number of wire connectors in used, well, that in should be out. So I'm going to ignore that in. The number of wire connectors used inside the box. Okay. All right, let's see what we have to deal with here. Here's a table 23 in the CEC, Canadian Electrical Codes. What do we have in this table? Here's the box dimensions, trade size, and of course, that's kind of a funny thing that we have in Canada, because look, those sizes here are specified in inches, and the capacity or the volume is mentioned in milliliters, but they also make it convenient for us that because in brackets they mentioned the equivalent in inches cubed. All right, so box dimensions. So octagonal box, 4 inches by 1.5 inch. Octagonal box. That's the size of one of the sides, since they're equal. And then this last number specifies the depth of the box. So for example, if it's a square box, only one side is mentioned because the other ones are equal. It's a square, right? So 4 by 1.5 inches. This is a box that is 4 inches by 4 inches by 4 inches by 4 inches. So just one side is mentioned. And the last one is the depth. All right. So of course here, let's say a square box, 4 by 1.5. And it's a 4 by 2 1/8. So obviously the second box is deeper. So look, the volume of the first smaller box is going to be 344 milliliters or 21 inches cubed. And of course, this box is deeper, so of course it's going to have more volume. We can fit more water in that box, if you will, although we are not going to pour water in those boxes. If you see water in an electrical box, that's not good. All right, so then there's 4 and 11/16 by, they're different by inch and a half. There are different square boxes, different sizes for different applications. Here's a round. This one shows the diameter of the box and the depth. So 4 inches by ½ inch. It's a ½ inch deep round box with 4 inches of diameter. And here are device boxes, 3 by 2. That's considered a single gang box. What's a single gang box? Okay, so the box that we used in the lab, the utility box that we did. It's considered a single gang box, which means it's 2 inches wide. It's 3 inches longer side, and there's the shorter side, which is horizontally mostly considered as a mounting. So 3 by 2, and here's inch and a half, or 3 by 2, because now if it's a device box and it's not squared, and of course you have to specify the two sizes. So single gang box is always going to have 2 inches wide. If it were a double gang box, it would be just like sticking two of those together, so it would be 3 by 4. And if it's a triple gang box, it would be 3 by 6, because every single gang of the box is 2 inches. And sometimes you see those switches cascaded in the multiple gang or gangable boxes. All right, so let's see what we have here as we continue going along the table here. Maximum number of conductors per gauge size. All right, so we have gauges. Gauge 14, gauge 12, gauge 10, 8, and 6. All right, so let's look. The gauge 14 is the thinnest wire. Remember, it's inversely proportional, the size of the gauge, the number of the gauge. If it's bigger, that means the wire is thinner. If the gauge is smaller number, then the wire is thicker. All right. Okay, so let's see. Gauge 14 wire. Let's take a look at the square box. Oh, not square box. Let's device box here. For example, 3 by 2, inch and a half. Just a regular type of a box. How many wires can we fit there? If we have 14 gauge wires, we can fit 5 of what we are going to consider as a conductor. 5 of those can be there and be still legal. Now, if we move up the gauge, which means the gauge number goes smaller, which means the wire is thicker, then the thicker wires, gauge 12, can only be 4 in that box, and you are still legal. And then as the gauge goes up, the number of wires that we can fit in that box goes smaller. And just by this same logic, you can apply this this way of thinking, or way of looking at things, to any of the sizes of the boxes and the types of boxes, and as far as the conductors. Now, table 22. Okay, size of the conductors and how many milliliters on the average of insulated wire, how much space it actually takes. Size of the conductor in gauge. So let's say 14. If it's in the box, it is going to take about 24.6 milliliters. And of course, if you go down the table, thicker wire, gauge 12, is going to occupy more space. And just so we can basically see this table as some sort of a rough reference on how much space do wires take. All right, now we're not going to go through the whole thing. Of course, by the time you are comfortable with reading the electrical code or finding yourself around the electrical code, you might as well sign up for a law school, because then you're going to be prepared to reading the legal language, pretty much. All right. No, okay, I take it with a grain of salt, what I just said, but it's kind of pretty close. All right, so what is considered as a conductor? Because first we say, we can fit so many conductors in such and such box. So what is considered as a conductor? And I'm just going to start you up on that, and then you can start reading, and you fall asleep about here, and then you wake up and you keep going here. Just kidding. All right, so maximum number of conductors in a box. What is considered as a wire, as a conductor? All right, boxes shall be of sufficient size to provide usable space for all insulated conductors contained in the box. And of course, here comes the legality things subject to following. All right, a conductor running through a box with no connection therein shall be considered as one conductor. Again, a conductor running through a box with no connection, it's considered as one conductor. What would be the situation? Well, there's a box and there's a conductor that you're pulling in from one end of the pipe, and it goes through that box and continues through another conduit or pipe, and it's terminated somewhere else further down the pipe. But that wire is not connected to any of the devices, if there is one, in that box. It is considered as one conductor. All right, so here, there's a number of conductors already being used. All right, B, each conductor entering or leaving a box and connected to a terminal or connector within the box also shall be considered as one conductor. Okay, so if you have a wire or conductor running through a box and it's not connected to anything, it's considered as one conductor. As soon as you cut the wire and that wire is going to be connected to some screw terminal, then out of the two conductors, you're counting that one conductor as two. What do we have here? C, a conductor of which no part leaves the box shall not be counted. So if there is a wire or a conductor that connects one screw terminal, for example, to another screw terminal of whatever device, it's just like it's not there. It is not counted. All right. Now, number 18 and 16 gauge wires, fixture wires, supplying a luminaire mounted on the box containing the fixture wires shall not be counted. What this is that sometimes you have a light fixture, and out of the light fixture, there would be wire or wires connected to the light bulb sockets. And out of that, whatever the assembly, there is a wire or two or three or four. And usually there will be 18 or 16 gauge wires. And what do we say here? Number 18 and 16 gauge fixture wires supplying a luminaire. A luminaire is a light fixture mounted on the box, so that that light fixture is mounted on the box containing the fixture wires. Those wires are not counted. All right, so that's how we read this thing, and you can just keep going with this and get into the details, which we're not going to go through because this is not a code class. I'm just giving you some sort of main kind of a frame of idea. All right, I'm looking at the chat. Okay, somebody is still laughing at the other things. Okay, cool. All right, what do we have in the next slide? Let's take a look at what things look like, shall we? All right. What do we have here? Remember when I was talking about single gang box? A single gang box is 3 inches by 2 inches. And this is the depth. All right. 3 inches, 2 inches. This 2 inches width here, these are the mounting screws for the faceplates. This one here, and this one here. It takes something that's called 632 screw to mount those. But this side here, that 2 inches, this makes it a single gang box. So a single gang box, 3 by 2, that is 2.5 inches deep, can fit 8 14 gauge conductors. And of course, what is a conductor? That's the guidelines that we're going to use, right? All right, let's keep going here. Single gang device box, most common size and uses. Use number 1, 3 by 2, so that's in inches, and 2.5 inches deep. The last number tells us, remember, the last number tells us the depth of the box. And that is mostly used for duplex receptacles and switches. All right, now let's see here. We got 3 by 2, so it's still single gang box, but now it's 3 inches deep. See, extra ½ inch of depth that we have here. If you have something that's called a GFCI receptacle, which is bulkier than just a just one duplex receptacle, because GFCI has some circuitries. Now, when please remind me to explain to you what GFCI is. I would rather do this thing in our in-person class than online here. I want to have an eye contact with you just to make sure that you guys understand what's going on. And I just want to explain things nice and truly, well, because we are a college, not some sort of fly-by-night kind of Almeida University. All right, if you know what I mean. All right, so for the GFCI, because GFCI has some circuitry in it, and that receptacle on the front, it looks very similar to the duplex receptacle, but it does have some circuitry. So the guts of this receptacle are bulkier and bigger, which means we need a deeper box. Right? Now, front face of the box extends in front of the stud or a drywall ½ inch. You know what? Give me a second here. I'm going to fire up my little board so I can explain this thing to you. Most of us probably, some of us might know what I'm talking about, but it's a school, so let's Okay, what's going on here? That's not what I wanted. Can I do this? All right. It's firing up. I should have started this thing ahead of time, but I didn't think I was going to need that. New file. Ah, what am I doing wrong here? New file. Oh yeah, okay, got it. All right. We have our board happening here. Just change the colors of the pencil. All right. So if we look sideways, like, okay, if you look at the front, here is a wall, and here's going to be a receptacle, single gang box with the receptacle, right? Now, we look at the same thing sideways. Let me erase that. If you look at the same thing sideways, that's the side of a drywall. No, that's not a drywall. That's the side stud, a frame. So when you mount the box to the frame, so this is the front, and this is the rear. That's where you are going to be standing in the room. And this is where all the back of the wall is going to be. If you mount the box, you're going to extend that ½ inch. This is a framing stud. And this distance here is ½ inch because when that frame is going to be covered with the drywall, the thickness of the drywall is ½ inch. So that's why it says here, the front face of the box extends ½ inch in front of the stud for drywall. Now, see here, if you look at this kind of a nipple right here and that one there, from the face of that box to that, you can't see it clearly. There's about ½ inch distance. So there are those guidelines. So you don't have to use your marker and a ruler or some sort of a something. You just put it to that point, and there you go. Everybody happy. Okay. All right. See right here. These are those nipples right there. And the box extends ½ inch. So when the drywall comes on top, the face of the box is going to be flush with the drywall. All right, single gang boxes with devices terminated. So here's a single gang device box. And what do we know about single gang? That means that right here is 2 inches. That makes it a single gang box. If it were a double gang box, it would be 2 inches and 2 inches. It would be just wider box. So here is a switch, and here is a switch. This one would be a 4-way switch, and this would be a 3-way switch. And we will talk about what those switches are. But just an example. Okay. Single gang device box cover plates. Sometimes they are called faceplates. Well, this is what a duplex receptacle faceplate looks like, for example. And this is what a switch faceplate looks like. Wow. We're talking some high technology here. All right, look at those. Two gang, double gang box device. Instead of the 2 inches, we have 4 inches because it's just like joining two single gang boxes. This one is still 3 inches, this length here, but each single gang box would be 2 inches wide. So a double gang would be 4 inches. So there you go. You got 3 by 4. And of course, the last number shows us the depth of the box. Now, this box can contain 16 14-gauge conductors. Oh, wow. Let's keep going. Yeah. Here's a 4-inch square box. Now, because it's a square box, we don't need to say 4 by 4 because square means you just have to specify one side of the box. So it's 4 by 1.5. What does that tell us? That it's 4 by 4 by 4 by 4 inches, okay? And it's 1.5 inch deep. All right, now this one here can contain 14 of 14-gauge conductors. Now, in brackets, it says here, not often used in residential wiring, exception cable connections with no devices. So, well, it's almost, for the most part, there would be no devices mounted here, but you could have this thing used as a junction box where many wires pass through that and they go through various different devices, and maybe some of the wires could be connected to some other wires within the box, and kaboom, the faceplate would be put on, the face cover will be put, it's like a blank faceplate, and that could be used as so-called a junction box for the most part. In commercial, maybe there will be some devices, like for example, well, fire alarm strobe light could be mounted on one of those, things like that. All right, 4-inch square box as a connection point for a circuit. Connection point, that's an example of a junction box. You see there's some wires going on here, there's some wires coming out, and some of the wires are connected internally. They're going to be shoved in and covered. Notice this one also is sticking out 1/2 inch from the stud to compensate for the drywall. That's going to come on later. All right, triple gang, 3-gang device box, triple gang. Of course, what does that mean? This is still going to be 3 inches. And over here, it's just like having 3 single gang boxes. 2, 4, 6, 3 by 6. And this one is, as number says, the depth of the box, 2.5 inches. 4-gang box. We're going to go up to 57 gang. No, just kidding. All right, 4-gang box, of course. 2, 2, 2, 2. That's 8. 2 plus 2 plus 2 plus 2. That gives us 8 inches. So that would be quadruple box or 4-gang box. And this one, for example, this one can contain 32 14-gauge conductors. You could look at some of the light switches in the classrooms because you can have some multiple gang boxes with a bunch of switches, light switches. All right, different kinds of boxes. Plastic 4-gang box. What would this be used for? Well, that looks like a back of the backing wall for a flat screen TV. Swiftly thought because all the connections and all that, they're kind of recessed in there. So the flat screen TV that we're going to put on top doesn't have to extend too much forward. And not just electrical devices are being put in here. It's like, for example, there's only one electrical device, which is duplex receptacle right here. And over here, we have signal wires. If you're interested in that kind of stuff, let me know. I'll point you to the appropriate distributors that sell those things. Quite often used in home theater setup if you're interested in making those. Those are fun. Now, again, for flash mount flat screen TVs. You could have it this way. You could have it that way. Right? Different there's all kinds of device boxes and faceplates out there, right? Now, gang ball boxes. Sometimes you, like, for example, the boxes that we have used in our lab number 2, that we mounted the duplex receptacle in the single gang utility box. It's the way it's just made, and that's it. Now, a gangaball box is almost like a Lego type of a scenario that we have here. You can take you can disassemble some of that stuff. So you can take the side off from one box. You can remove also another side of another box, and you can screw them in together to compose a double gang box out of the 2 single gang boxes. Now, it's always a good idea to have that in your stash, to have that in your van, in your inventory. If you're in the pinch and you don't have that, you can make two gang box or double gang box out of 2 single ones, and you can complete your day. If you are participating in a larger project that you have to use a lot of those multiple gang boxes, of course you're going to prepare your inventory accordingly. You're not going to waste time on disassembling and assembling boxes like this for, let's say, 60 locations. This is convenient when you need that and you don't have so you don't have to go to the store and buy triple gang box or 4 gang box. You can assemble that, right? And that's what comes out of it. See, you can join that and make a double gang box out of 2 single gang boxes. Whoa, where were we? We were here. All right, other type of devices. Sometimes you're going to install a device box in a wall that is already covered by a drywall. Normally, the perfect scenario and the dream kind of a scenario would be to have a bare frame without the drywall mounted, and you mount the boxes to the studs, and then the drywaller company comes and installs the drywall. However, sometimes first the phone rings, then the dog barks. What else is going to happen? All right, we're almost done here. So sometimes you're going to have to install a box in a place where the drywall is already there. If somebody requests an additional receptacle or something like that, so it could be a retrofit job, or it could be just a service call that somebody requested, and then you don't have access to the studs, or it just has to be in a specific location. It just happens to be between the studs. These are called the F clips because it looks like a letter F. All right. What does it say here? gang about boxes. Used mostly for adding devices. So here, for an existing installation or retrofit, F-straps or F-clips. Pin the box between the inside and outside surfaces of the drywall. Cables for the retrofit are brought to the hole for the box behind the drywall. Fishing, and now I'm going to show you what fishing means. It's not going fishing, it's fishing the wires in the wall. So you cut out the cavity for the box, you fish the wires through, but the box has to be mounted onto something. But there's no stud on either side. That's where the F clips come in. And some of the electricians, they carry a lot of them in their vans just when they need it, so they don't have to go to the store. And I would encourage you to look at, well, here's that thing that's called YouTube University. So go there. And there is a short, usually there's, I saw there was a short, like I don't know, less than a minute video on how to mount those things. These are pretty good things to have. Can save you a lot of time and often make your job passable at all. All right, common devices used with gang boxes. Single pole switch, duplex receptacle, single pole, double pole, single pole, single throw, single pole, double throw switches. This is a single pole switch. That's the simplest switch. All right. Here's a wire. Here's a terminal. Here's a terminal. Your wire continues. Here's the pole. Single pole. Single throw switch. This here, if there's a terminal and there's a terminal and there's a terminal, there's a wire, here's a wire, here's a wire, here is a pole. This would be a single pole double throw switch. You can throw this pole into this terminal or that terminal. So there's a single pole double throw switch right here, and there's a single pole single throw switch. If you had a switch like this, and quite often these would be joined, this would be double pole single throw switch. That's how it goes, right? So this is a single pole switch. Cool. Duplex receptacle. Well, common devices. All right. Duplex and split receptacles. A duplex receptacle has brass side tab removed in order to make a split receptacle. See the other one I showed you here? Now, what you could do is you could break that connection here, which means this, if you wanted to connect that hot terminal, it has to be connected to this screw, and it's going to be independent from that hot terminal that can be connected, that is joined inside to this screw. What does that give us? And you can leave the neutral intact. So what does that give us? It gives us one neutral return path, and you can connect one circuit breaker through a wire to one of those, and you can connect another hot from another circuit breaker to the other one. And this way you have two separate circuits, mostly used in the kitchen countertops where the receptacles get used a lot, especially in the morning. Everybody wakes up, there's a toaster going, there's a coffee maker going, there's some whatever else going, This can fill up pretty quick, and it takes more current than the usual receptacle that's in your living room where you only have your TV plugged in, and that's it. All right, so that's where the split receptacles are most common. And of course, the ampacity is bigger than usually, normally 15 amps, but it's also a good idea to install 20 amps circuits. So not only you have a split independent receptacles, duplex receptacle with independent circuits here, but also it can handle more current. This is what a 20 amp GFCI looks like. This is what 15 amp GFCI looks like. And please remind me, I'm going to try to remember to explain to you what GFCI is. 2015, what's different? It's the footprint of that. You see here, if you have a load that requires 20 amps, the plug at the end of the cord is going to have that shape, which means you won't be able to plug it into this receptacle that only is able to provide 15 amps. But the receptacle that is able to provide 20 amps is going to have that footprint. So the plug that has prongs shaped this way actually can go in. And here are the examples of different footprints versus the different ampacity. Those not grounded are, pretty much not installed, but that's what they look like. And there are different footprints for different receptacles depending on pretty much the ampacity. And ampacity is to the ability to conduct current. Right, so that was the last slide. It's 10:02. I gotta set up for the next class, which is the same for the sections 2, 4, and 6. And okay, can you plug something meant for 15 amps into GFCI 20? Yes, you can. Here's a question. If the receptacle can provide 20 amps, can you plug in something that requires only 15? Yes, it is the load that decides how much current flows through the circuit, not the receptacle. The receptacle is able to provide, but it's going to give you as much as the load is going to pull. So for example, you have 15 amp regular circuit in your living room, and your lamp is going to pull maybe 2-3 amps out of that. Even though the receptacle can provide 15, it's not going to try to push 15 amps through it. It's what's pulling what counts. Okay, so yes, you can plug in a 15 amp load into a 20 amp circuit. Okay, cool. All right. So what's today? I want to wish you a great weekend. It's only Monday, but hey, it's almost Friday. Why? Because every day is almost Friday. And on that happy note, I'm going to say, I'll see you when I see you. Thank you. And I'm trying to find those buttons to stop the Zoom. There we go. I should get some shortcuts for this.